So, welcome back, everyone, and let's focus on machine learning aspects in one more live demo here, where we would be focusing on machine learning success stories, where we would be loading the live data set from mobile phones. Okay, so whenever you go to your mobile phone, generally there is an app. Okay, so I just wanted to open up the video here, but what would happen is that I heard that you're not able to hear the voice. Now what I'll do is that parallelly I'll play those videos so that you can understand like what I'm trying to tell you. Now whenever you are using an Android phone, what happens is that the amount of sensor data would be very large. Why is that? Because each mobile phone would have somewhere around seven sensors available in each and every mobile phone. Okay, so your interest is to capture that real-time data and then process it on real time, and then apply machine learning algorithm after pre-processing that mobile sensor data. And based on that, your new set of sensor data, when it has been loaded to the same machine learning algorithm, it should tell you that whether the person was sitting, standing, moving, walking, or standing. Okay, so like that, it might be you should be able to classify the data on real-time scenario. So in this regard, okay, let me just come down here to my MATLAB window here, and give me 1 minute. I'll just load the data set. Day-4. Okay, so what we are trying to do is that there is a data set which is your raw sensor data set, which is obtained from the mobile phones. Okay, so we'll take this corresponding sensor data into what is called as MATLAB, and then we would be processing this corresponding data on a real-time scenario. Now the first question is like how exactly you would be able to capture that corresponding mobile data on a real-time scenario. Okay, so you can see here whenever you go into what is called as MATLAB or Google Play Store, you can download an app called as MATLAB Mobile. Okay, so once you go here, you would be able to download that corresponding app. Okay, so just go here and then type MATLAB Mobile. What would happen is that it would show you this particular MATLAB app, where you can just go ahead and then install that corresponding app on a real-time scenario. So once you have installed this corresponding app, you can just go ahead and click on open here. Okay, now once you click on open, what would happen is that it would ask you your MathWorks email ID, that is the license version. So you know that like MATLAB licenses can be purchased at somewhere around 4,500 plus using the online MATLAB suits, okay, which is up there in which can be installed into your personal systems also. So once you're done with that, you can just go ahead and then install that particular MATLAB license into your system. And then once you have installed this corresponding MATLAB software into your system, what would happen is that you would be able to log in via the credentials which you have given. Now, once you go ahead and then say continue, what would happen is that you would be getting a mail from mathworks.com, and then you have to acknowledge that mail. And once you acknowledge with that mail, you would be able to allowed to once the verification is done, you enter your license details, and then you would be able to use the MATLAB software in your mobile phones also. Now you can see you can store have somewhere around 5 GB of MATLAB mobile data there. Okay, or it might be your images or different files can be stored in that corresponding location of yours. Okay, now you can work on the MATLAB software individually on your phone, and then you would be able to process that corresponding data. But this is not what we wanted it. We wanted to capture the live data. Now how do I collect the live sensor data? Now once I go into my mobile phone here, okay, so once I have downloaded that app, what I'll be doing is that you can see here I have loaded into my drive now. Now if you want to perform any live image processing or audio processing, what you can just do is that you can just take a photo and store that image into the drive. Okay, so whatever drive which I just showed you, you can save that phone or image into the MATLAB drive, which is inside that MATLAB mobile app. Now you can go ahead and then perform edge detection or display that corresponding image with the file location. It would display that image and then you would be able to rotate it, perform edge detection. Okay, so like that you can perform different operations on your mobile phone itself. Okay, and then once you have done with the edge detection, you can see here, if you go into the options here, if you go to the third option, there is something called as sensors. Now, when I click on the sensors, you can see that inside your mobile phone, there are different sensors like accelerometer, gyroscope, angular velocity. So there are different kinds of sensors which you can use in. And then if you go into stream in and then say log, what would happen is that it would automatically send your data, that is your latitude, longitude, that's your GPS data, directly into your MATLAB cloud and to your system. Okay, now once I have sent that data, what would happen is that you can see that when the data was sent, it is basically the walking data log.mat. So this file format would be directly sent to your system, and this is where you can see that there is the MATLAB sensor data which has been captured. And then if I go ahead and load that data, it will have the data associated to latitude, longitude, speed, course, and so on. And then you can check what is the distance you have traveled and so on. So this is a simple way, the fit bands what we see these days, like it might be from say any application. You can see that that particular fit band data can be taken, built using the mobile sensor data which we are just showing it to you. Okay, the second option is you can just go into that UCI website. Okay, there also you can go ahead and directly, instead you want to have, you don't have time to what is called as use your own mobile phone ka data set. Already in this particular website you have the data associated to the mobile phone. Okay, so there is something called as human activity data set which you can go ahead and download from this particular location here. I think it's, so the human activity data set. Yeah, so human activity data set can be downloaded here. Okay, let me just go back. Was it here? Yeah, so you can see that intelligent accelerometer and gyroscope data. So you can basically capture this corresponding data. Okay, download this corresponding data set using this particular uh, folder location, and then you would be able to download and save it into your system. Now, once the data set is being downloaded, you can see that I have the raw data set, that is UCI har data zip file. So I have extracted that data set. What would happen is that you can see this is that raw sensor data which is out there. Now, once I have this corresponding raw sensor data, what I'll do is that you can see here, this is the data which is captured from a mobile phone at 50 hertz. And then it is captured for a sliding window. That is the entire time duration which it has been captured is for 2.56 seconds. So which has somewhere around 128 readings per window. And then this mobile phone data, sensor data, when you're capturing in, what they had done was they had performed different operations. That is, the person was carrying the mobile phone with him, and then he was parallelly walking, climbing, sitting, standing, and laying down on the ground. Okay, so once this is being done, what are the two set of data set which we are concerned about? One is your accelerometer data, the second is your gyroscope data. So whenever you talk about accelerometer data, it would also have your X, Y, and Z quadrant, and your gyroscope data also would have X, Y, and Z components in it. Okay, now once this is being done, there is an option where if you have not downloaded, if exist, you will be able to download this. Since I have downloaded it here, okay, so I would be starting up with my programming from here. So in the first section, what I'll do is that there is a sensor data which is called as load raw sensor data underscore train. So what I'll do is that let me just go ahead and run this corresponding algo. Now if I go here and then click on this data set and then go, I mean, this variable here, that is, as I said, gyroscope has XYZ and accelerometer also has XYZ. Now I'll select one and then I can just go ahead and plot it. Okay, so you can see this is how the sensor data set of your X quadrant of your gyroscope data set would look like. I can also go ahead and then select the accelerometer X train data and then I can project that, right? It looks like this. Now, in my case, what I'll be doing here is that I'll be plotting the sensor data with respect to X, Y, and Z of accelerometer data and the train activity in terms of 1,000 samples. I'll be plotting it. So once I go here into my editor window and run these two lines of code, what would happen is that it would project up the sensor data. Okay, so in the sensor data, you can see that whatever that sensor data was there, okay, the raw data, you can see that yellow representing the climbing stairs, green is there which is representing what is called as walking, you have red which is basically sitting, and then you have blue which is the sensor data associated to people lying in, and then you have purple, okay, and red which looks similar, where you can see that the person is standing and the person is sitting. So whenever you are having a mobile phone with you, when the person is standing and when the person is what is called as sitting, you can see that it looks similar. When the person is basically climbing the stair, as well as the person when he is actually walking, okay, the green and yellow, they look similar, right? So from this only you can actually apply what is called as classification learning app on whatever data set which you have in, where your data set is being projected in terms of something called as a graph on a real-time scenario. Okay, now once this is being done, you would be able to pre-process the data. Okay, so for that you have said what human activity, where fun, you take the mean of entire raw sample data, because we said that we are taking the fixed sample width of somewhere around 2.56 second, where we are taking 128 readings per window. Okay, now I'll be performing the pre-processing by taking the mean of the entire data sets. Okay, now once I have taken the mean, you can see that there are variables which are being created in, and now once I have taken the mean of that corresponding variable, I'll go ahead and load my learner app, that is my classifier learner app. So previously we had used it for flower classification. Now what I'll be doing is that I'll be using it for sensor data classification, where my sensor data which has been loaded into the machine has to tell me or segregate the real-time sensor data as whether the person is standing, sitting, moving, walking, and so on. Okay, so let the data load here. So I can just go here. What is the step? Go to new from workspace. Now it will tell you what is the data set which you want. You can just go here and then click, go ahead and then select human activity. Now you can see that there are accelerometer data, gyroscope data, and under category, there are 5 unique categories. I'll keep the crossfold to somewhere around 13 here, and then that reduces my overfitting condition and increases my accuracy. Now, once I say train, what will happen is that this data set would get trained. Okay. Now, okay, you can see that this is the human activity data set, where blue represents what is called as lying, red sitting, yellow climbing, purple you're not able to see it, and then you have green. Okay, you'll be able to rotate this also, but I'm not interested to do that. My intention is to train this corresponding model. So let it be in fine tree only. Okay, I'll keep it in fine tree only, and under decision tree, let me just go ahead and train the model. So the same procedure, it would turn on the parallel pool, and once the parallel pool is turned on, what would happen is that it will start training the machine. It's similar to the way like when we are very small, kids generally come and ask you, like when they are seeing the frog for the first time, they have a tendency to get afraid and they'll ask you, what is that? You say it is a frog. Then again, the second time, they'll come go to their grandpa and then they'll say, what is that? Frog. Multiple times they do it. right? Similarly, machines also have to be trained in a similar fashion, where we divide the data set as 70% for training and remaining 30% for testing, right? The same procedure is being followed here also. So initially, you apply machine learning, train it, and then once the training is completed, it gives you a model, and then you pass the new set of input with to see that whether it is classifying the data correctly or not. Okay, so let the parallel pool start in and let it continue. So in the meanwhile, let's come back here. So why this particular machine learning algorithm uses data, okay, and produces a program to perform a specific task. Now, whenever you talk about artificial intelligence, it is basically used to develop computer systems to perform tasks that are normally require human intelligence. Say, for example, whenever the car is moving on a road, so you can see that this is a semantic segmentation based road identification as well as vehicle identification on a real-time scenario. Okay, and then if there is a robot which has to be moving around, so you would be mentioning that this is the location which I have to reach. But what would happen at certain scenario is that when the robot is moving in, you might have written a program for one. Each tile would have two steps, so 2, 4, 6, 8, 10 step, and after that you take a right if this is a location which you're trying to move in. But after some time, if your robot is somewhere here, will it reach this destination? No. So machine has to automatically learn by itself, okay, so that it reaches its target on a real-time scenario. So that is where machine learning comes into picture. One such kind of scenario is that this is where you can see that the Google car is able to drive by itself on a real-time scenario. I'm sorry, on a real-time scenario where uh, you need not drive the car would automatically drive on a real-time scenario. And you can see that basically the people who are sitting inside the vehicle, okay, so these are the founders of Udacity, and this is a video reference from their course, and where you can see that this entire vehicle is self-autonomous, and this was developed for one of the competition which generally happens in US. And later you can see that Google and as well as we have Volkswagen and Volvo who are coming up with these self-driving cars, and Tesla is also extensively investing in these kinds of vehicle where the vehicle can drive automatically autonomously, where you open the door and tell the location. You do not wait for these cars to come to India. These cars are already been tested in in India, okay, in Hyderabad, in Bangalore, okay, and it is able to drive efficiently. The only problem in India is that generally, whenever the person is driving behind an auto or when the person is getting down from a bus, okay, it's very difficult for a self-driving car to understand the synergy. So that is one of the difficulty. The second difficulty, what we just observed was, especially, it is able to identify the traffic lights. Okay, but whenever there is a changes in red, green, and orange, so that classification part there, it's finding it bit difficult. So that's where if the camera quality is not capture that data, especially in the sunlight, it is not able to capture. That's the one of the area where a lot of people are extensively working with. Okay, in the meanwhile, let me just stop this here and come back here. You can see here now, using whatever the sensor data set which we just loaded in, you are getting an accuracy of somewhere around 80.8%. Followed by that, I can just go here and then I can also select say quadratic SVM, and then I can go ahead and train the model once again. So it is queued. So whenever you apply different machine learning algorithms, it's basically an iterative process where based on your data set, say for example, in the previous algorithm, we had fine tree algorithm giving us the better accuracy. It was more than 95. Now you can see the accuracy has reduced to 80.8, right? It's ideal that you have an accuracy more than 95%, okay, which is general acceptance value. Okay, it's more than 95, it's ideally acceptance. But again, there are various other parameters like f score, we have precision, and we have say different parameters on which you will be actually evaluating whatever model which you have built using machine learning. Okay, now let it train parallelly. In the meanwhile, let me just come down here and then show you the confusion matrix. I think this would give you a rough idea like what is confusion matrix. Once again, because I'm doing it for the second time now, I can just go ahead and click on confusion matrix. Now you can see here, basically there are something called as true class and predicted class. Okay, so this is your true class and then you have this as your predicted class. The person was carrying mobile phone with him and then he was lying on the ground. So it got identified as lying. So it is somewhere around 1407. So the amount of data set which you had was 7352 into 128. That large data set which you just loaded. Okay, so imagine in a classroom which you take, each student would have two mobile phone and each phone would have somewhere around seven sensors. Imagine the amount of data going into the cloud. Okay, so that's the reason we started off with IoT, and then how exactly the data you can access. Now this is where you have downloaded the data and then you are working on it. So here in the second case, you can see that in the confusion matrix, the person was having mobile phone with him, but he's sitting. Did it got identified as lying? No. Sitting got identified as sitting? Yes. Sitting got identified as climbing stair? Yes, 21. Sitting got identified as standing? 105 samples, right? So machine is really confused here. Now, when you look into the climbing stairs, when the person is climbing, did it get identified as laying? No, but did it get identified as sitting? Yes. Climbing stairs, but got identified as climbing stairs 1659, and climbing stairs also got identified as standing, that is 71. But climbing stairs got identified as walking, because walking as well as climbing stairs, when we saw that graph, in that graph also it looked similar. So it will be ideal that machine would not be able to classify that in a precise manner. Okay, so this is how your machine learning algorithm would be able to classify whether the person is lying, sitting, standing, walking, moving, or so on. So what you can do is, let me just go ahead and stop this, and then you can export it as a function also. Last time I just showed you to export it as a model. Now you can also export in this option. If you just go ahead and click, you can now export that model as a function also, and then you would be able to use it extensively based on whatever models which you generally want to use in. Okay, so this is with respect to the human activity learning, where your intention was basically to identify whether the person was sitting, standing, climbing, walking, and moving. And then once you have imported the model, pass the new set of data, it should be able to perform these classification options. Okay, so I've stopped my I have not applied many machine learning algorithms. I have shown you how to apply different machine learning algorithms. You can obviously go ahead and apply different machine learning algorithms and try whether you're getting correct output and reaching the corresponding accuracy or not. Or you can also download your own mobile phone ka data set, okay, and then you would be able to work and get the corresponding accuracy. Okay, now once this is being done, let me just go ahead and close the classifier learner app and close app, minimize this, okay, close this, no, no, and let me just go ahead and then clear things here. Okay, now once this is being done, let me just come down to our presentation here. Okay, so we just saw ADAS. Okay, so there were questions like, yes, are there any methods through which I would be able to work with automatic driving assistance system? Yes, there are methods. Okay, and one to be shown is your ADAS application, which is out here, and you would be using a ground truth labeler to identify vehicles at what distance they are moving in and what is the uh, how exactly semantic segmentations can be performed on a real-time scenario. So to do that, what I'll do is that let me just escape and then come down to MATLAB once again, and then I can just say ground truth labeler, and then I can just load a video which is somewhere around zero point 0.5 highway lane 25 seconds dot mp4. This is the file which I've just loaded into my MATLAB. Okay, now what it will be doing is that we are loading a live video, and from the video, imagine you are sitting in front in a car, and then there is a camera, and the car has to automatically identify the vehicles which are being moving in front of it on a real-time scenario. So that is what you are trying to analyze from this particular model here. Okay, so let the video load in. Right now, what I can do is that let me just keep it in maximum mode. Right now, you can see this is your ground truth labeler app, and inside that you have loaded a video 5 highway lane 25 seconds ka video. Now, if I go ahead and then click on this play button here, what would happen is that you can see this is the live video which is being captured, and it is an inbuilt video which is inside what is called as MATLAB. Now you have to write an algorithm where the vehicles which are being moving in front of you have to be identified, like the video which we just saw in the morning where the Volvo vehicle was able to identify the vehicles on a real-time scenario, right? So let's go ahead and build this corresponding model. So this is the entire video which we have captured, or which is there inside MATLAB, which you have just invoked inside what is called as the ground truth labeler app. Right now, what I'll do is that you can see here, I can go into the right corner here. Okay, I can go into the right corner here and then select on label. Okay, and then I can just come down here and then I can just say VEHICLE. That is the name of the label which I want to give. Okay, here if you want to identify lanes, you can just make it as in terms of pixel also, but my intention is to identify vehicles. So you can just go ahead and then say or identify vehicles. I'll just keep it, or vehicle identification. It's up to you. I'll just say okay now. Now observe to my cursor here. Now you can see on the right corner there is a label, that is region of interest is my vehicle is being created in. Now I can just take this plus mark here, and then I can just go ahead and draw a bounding box on this corresponding vehicle. So just click, drag, and then you would be able to draw a bounding box on a real-time scenario. You can also draw one more bounding box here. Okay, what happened? So let me just redraw it. Draw this one. Redraw for this one. Right. So I'm aligning my vehicles in a precise fashion now. Now, once you have identified or drawn the boxes or the bounding boxes, what I'll do is that I'll go here and then click on attributes. Okay. And then here I can just label it as VEHICLES. Okay. And then I can just name it as car, enter. I want SUV, and then I can just say Jeep, and then I can say truck. Okay, so these are the list of vehicles which I want the attributes to be filled in, and then I can just go ahead and then say okay. Now once I say okay, on the right corner you can see that these vehicles have been identified. Now whatever is in yellow, it is an SUV, so I can just go here, click on this, and then go ahead and select SUV there. Go to the second block, click on it, Now that is also an SUV. Go to the third one, click on it. So it's already a car, so no need of any changes. After this, you can just go ahead and then save the label. You can save the session. I'm just saving it, right? Now, once the saving is being done, you can just go here and then go ahead and then select the algorithm. So what we'll do is that we'll be selecting the ACF vehicle detector algorithm, and then you can just go here and then you can just say automate. So under that, if you have your own customized algorithm, you can load your customized algorithm and then you can load it. Okay. Or if you don't, you can also use the inbuilt point tracker algorithms. Or if there is any specific algorithm which you're working with, you can use such kind of algorithms also. Now, once I'm done with that, I can go to the top corner here and then say run. Can you see that? So on real-time scenario, you are actually able to identify that vehicle. So we had just put a bounding box on one vehicle. Now the 10 frames per second forms a video. So each and every frame, it is able to identify that corresponding thing on a real-time scenario where the vehicle is moving, and then it is also able to draw the bounding boxes on those rest of the vehicles also. Now observe that the second vehicle, okay, the SUV is also being identified, and observe now we are able to see the third vehicle, fourth vehicle, right? So those are the vehicles which we actually did not draw any bounding boxes. But on live scenario, you can see that those boxes are also getting identified. You can do it for pedestrian detection. You can do it for people tracker. You can do it for vehicle detection. You can also find out at what distance these vehicles are moving in on a real-time scenario, at what meter, like whether it is 65 meter, 70 meter, 80 meter. So if you have a stereographic camera, you can also capture such kind of data on a real-time scenario, right? So you can see this vehicle and all, we did not label, I mean, we did not draw the ROIs, right? These two vehicles. Now you can see those vehicles, when it comes within that vicinity or within that region of interest, it is able to identify them as vehicles. Now once it is able to give me better output, what I can do is that I can just go here and then say stop, and then I accept it's giving me correct output. And then you can also go ahead and then check the summary of whatever model which you have just created in. So if I go into the summary here, it will give me the entire summary of vehicles which were used or which was moving in that live scenario. So if you just go here and then click on summary, you can see that's the vehicle details, how many vehicles it has identified, and the scenario at which how many total vehicles, total 4 vehicles it has identified. Okay, so you can export the label as a function. So you can just say export to workspace or to a file. So you can just give your name and that file would get exported, right? So I think someone was asking me, where do I start up with? This is where like a combination of computer vision as well as your machine learning algorithms, you would be able to start with the self-driving models. Okay. So let me just clear this. So let me just go here. Let me change my current folder. Give me 1 second. Day 5. Yeah. So any doubts in this, whatever I just covered? Any doubts in whatever modeling which I just covered? You can just go to the chat box. I think there are no questions as such. Okay, then let me just go ahead and then continue with our session. Okay, before moving in, I think we just wanted to project one of the project which was carried out by Nisha from Kerala University, right? So what we did was we were able to automate things, and I'll not be able to explain you the entire program, and I'll not be able to share you that codes also, because it's an, I'm sorry, control set. I think I just copy pasted it there. Okay, so where is the file? So the same concept is being used here in this particular program here. Instead of using ground truth labeler, they have used the command, they have read the same video, but using what is called as your highway lane and using a video reader. So there is video reader uh, function using which they have read the video, and then they said they read the objects in each and every frame which they have read in. Okay, and then they also have read, this is the video data, and this is your monochrome sensor dot mat data which has been loaded together. And then once you have done with that, you are trying to identify, like we had used the same ground truth labeler app. Okay, uh, this is the ground truth labeler app. Give me 1 second, I'll just show you that also. Yeah, so they had used the video object, and then once you load the sensor data, you can see that it is able to draw the bounding boxes on real-time scenario. Okay, so this we did it with the ground truth labeler. So instead of writing doing it with what is called as app, they have directly used the detector is equal to vehicle detector, and then they have given the width, that is 1.5 and 2.5. So it is drawing that bounding boxes on those detected cars. Okay, and then you are telling that I want the shape in rectangle, and then there should be bounding boxes, and the title should be what is called as detected images. Okay, so once this is being done, what you'll be doing is that you'll be finding the midpoint of each and every bounding box. So you'll be finding the midpoint of each and every point because you're trying to measure the distance. Okay, so you generally know that if there are 2 points, okay, which is lying on the ground, how do you find out the distance? We find out the distance by Euclidean distance measure. How do I do that? X2 minus x1 plus whole square minus plus y2 minus y1 whole square, and take the square root of it. Okay, so I hope you remember the Euclidean distance method. The same way you are trying to do it here, where you are having 2 points, that is 1 and 2, where you are telling that distance is equal to square root of each and every point square plus y dot whole square, and take the square root of it. Okay, now once that is being done, you can see that here when you run that corresponding set of code, what would happen is that on real time, you would be able to detect. So in the first case, we were just load using the camera data. In the second case, what we were able to do was that you are able to identify at what distance this corresponding vehicle is moving in on a real-time scenario. Okay, so a combination of sensor data and other set of data, you would be able to build this model. So rest of the thing, you can see everything is commented here. So the same process, like open ground truth labeler, and then you go and mention it as vehicle, and then distance. So like that, we had used the easiest method where you are able to identify, but in this case using the app also, whatever the output, final output is there, you can do it like this also, where you are trying to identify vehicles. So choice is yours. Whatever method you want to use, you can obviously go ahead and then start working with the ground truth labeler app. I hope things are easy, right? So let me just come down here and then clear everything. Any doubts still here, or shall we continue? Okay, there are no doubts. Let me just go ahead further. Now, once this is being done, we are into a new concept which is called as deep learning. So, what is meant by deep learning, guys? I want you guys to give give your views. What is meant by deep learning? I think morning we had discussed about it. So, I just wanted to know from your end what is meant by deep learning, or how do we define deep learning, or what is the difference between deep learning and machine learning?
Hello.
Yeah, ma'am.
Yeah, in the case of machine learning, we want to extract the features from our data set. But in the deep learning, the neural network directly extract the features
Correct,
from the
ma'am.
data set.
Correct. Yeah. So in this section, focus would be what is called as deep learning. As Madam was pointing out, the difference between deep learning and machine learning. Okay, so these are the buzzwords these days, where whenever you talk about deep learning, okay, you can see that they are extensively used these days. Like it might be in small apps, like it might be Netflix, or it might be Amazon, Flipkart, right? So wherever you look into these kinds of data set, okay, me just minimize this. So whenever you look into this kind of real-time data set, I think I request the participants to be on the mute mode. Yeah,
While
thank
they
you.
okay, okay, fine.
Yeah.
Okay.
So whenever you talk about deep learning versus machine learning, the easiest takeaway for understanding the difference between machine learning and deep learning is to know that deep learning is machine learning. That's first thing which you have to understand. So, more specifically, deep learning is considered as an evolution of machine learning. It uses programmable neural network. Okay, it's not a normal neural network. It requires a programmable neural network that enables machines to make accurate decisions without the help of humans. So basically, whenever we had discussed about machine learning, we had said that it helps in performing tasks where uh, it's something that performs a function with data given to it, and then progressively performs better at each and every task. So it also performs recurrent learning at certain scenarios, and then you would be able to get better output. Now, whenever we go into deep learning, okay, so you can see that deep learning is a type of machine learning in which model learns to perform classification tasks. Like we had performed classification, right? I'll take that as an analogy, and then perform classification tasks directly from images, text, or it might be sound. So deep learning is usually implemented using what is called as neural network. The term deep refers to the number of layers. Okay, so one such great example which is your AlphaGo. Okay, so Google created a computer program with the help of its own neural network that can learn to play what is called as an abstract game board called as Go. Okay, and it was able to defeat the entire grandmaster of the same synergy. Now, deep learning structure algorithms in layers to create artificial neural network that can learn and make intelligent decisions from its own. So that's one important thing which you have to look into. And then deep learning is a subset of machine learning, while both fall under the board, or basically both fall under the broad category of whatever AI, which we had discussed in the first slide, where you have the power of human like artificial intelligence. Now, what happens in convolutional neural network layer? Now, whenever you talk about CNN, okay, I think last day I was just checking the agenda. I think everyone is aware by now because we had people from Deepak from Triple IT Dharwad. He has talked about Markov's model and various other wonderful speakers have already briefed you. But to be very specific, uh, I'll put it in simple words. Now, whenever you pass an image, it will be going through a layer of CNN, which we call it as convolutional neural network layers, where there will be combination of convolution, ReLU, pooling, okay, flattened and fully connected layers, and then you'll be having the soft max layers available. Now, once it goes through these layers, okay, what happens is that here the features would be extracted. Now, how does the features are extracted? In the first case, what happens is that when you send an image, okay, it will perform convolution. Okay, it might perform different kinds of feature extractions, like it may perform blurring operation, or it might be performing edge detection operation, it might be performing image enhancement operation. So image is nothing but a matrix, agree? So once that image is passing through those filters, what happens is, once the image passes through those images, what happens is that you'll be getting another set of matrix where it will be the feature connected matrix. So if there are multiple filtering operations applied on an image, you will get multiple what is called as featured matrices. After that, you can see that they are represented it in terms of a pooling layer, and from that pooling layer you would extract a specific feature, which are nothing but your dominant features. So whenever you're performing pooling, it will identify those main features, and then those features during the flattened fully connected ReLU layer, what it will do is that it will pass those features one by one, and then you would be able to identify whether this is the input, which is a cake, which is a cat, or a dog. Okay, the same operation you can perform it using what is called as the deep inference, or with say few lines of code where you can perform what is called as deep learning. Now, in this case, the first thing what I'll be doing is that I'll write a variable called as net is equal to lxnet. Okay, that would load up my convolutional neural network. Then I'll load a image which is called as imread peacock.jpg, and then I will resize the image because LXNet, everyone is aware of Alexa, right? So Dr. Alex and his team had developed this LXNet. You would resize the image, and once you have resized the image, you would say that classify that image using what is called as LXNet. So how exactly your MATLAB would be able to categorize, or whether it will be able to do that or not, let's go ahead and check that. So what I'll do is that I'll just move to MATLAB now. I'll take a new M file and then just say net is equal to lxnet semicolon, and then I can just say I is equal to im read, and then I can just go here and then use the command called as, I think, peacock, right? I can just say peacock dot jpg, right? Then put a semicolon there, I'm sorry, and then you can just pass one more variable, I1 is equal to, I can just say im resize. Okay, so why I'm resizing it? Whenever LXNet was trained with 1 million images with 1,000 classes. I'll show you all those 1,000 classes also as we go with the session. So I'm just going with the basic example. So I'll resize the image to 227 cross 227. And then once that is being done, you have to use a command called as classify. Okay, and then the variable name is net. And what is the image which has been resized, stored inside which variable? I can just say I1. Okay, so let me just put a semicolon here and then a semicolon here, and then let me just do this. Let's see, I'm saving it. You can see that it is able to identify that.
Sir.
Hello? Hello? Yeah, sir. Hello? Yeah, I think someone was speaking to. Okay, I request the participants to be on the mute mode. Okay, now you can see that you are able to identify that this is the image of a peacock. Okay, now if you want, you can just go ahead and then say I am show of I, and then you can display that image also, and then you would be able to process that corresponding data on a real-time scenario. There's a question here. Yeah, so there is a okay. So, sir, how can you determine how many hidden layers epochs are to be taken and which activation function have to be used for a particular application? See, basically, whenever you talk about hidden layers and the epoch, it is basically whenever you are performing the training. So when I go to the transfer learning, I'll brief you much on the activation layers and then the hidden layers. Okay, so where we'll be talking more about these concepts. Okay, so till then, please be tuned there and please concentrate. I'm just going it from scratch because we have almost 2 hours. So I'll talk about. Yeah.
ప్రమోద్ గారు సారీ అండి వేరే వాళ్ళని చెప్పి
Okay, sir. Should I continue?
ఎస్ సార్ కంటిన్యూ సార్
Yeah. Okay, so as far as the deep learning is concerned, deep learning is versatile and then it can be used for a wide variety of applications. So few of the applications, it might be in terms of object detection, which we just did it, but this can be in terms of recurrent CNN, or it might be in terms of semantic segmentation, or it might be sequence to sequence regression, classification of image using Google Net, or it might be in terms of deep learning and speech recognition. So such kind of things on real time, you would be able to do that. Now, in order to analyze this, what we have currently is, let me just go back to the slide. Yeah. Now, this is one of the program which we had. Now, what I'm doing currently is that, okay, so I have an image here. Okay, so you can see that the name of the image is mouse.jpg. Okay, I'm loading that image and then at the same time I'm displaying that image, and then at the same time I'm using what is called as an object name, which is called as char label. And then what I'm trying to do is that I want my model to actually convert whatever the classification or the category is there into a speech, and it has to speak out that this is the image of a mouse, parrot, or it might be anything. Now that is what I'm trying to do. That for that I'm just using net.assembly, and then I'm using a system.speech, which is a synthesis speech synthesizer, which I'm using it, and then I'm saying that the object volume is 100, and then speak the name of that corresponding image. But when you're running it, see into that it is in the same folder location. The image which I am loading here is the image called as mouse.jpg. Okay, now if I go ahead and then run this code, you can see that your mouse, okay, is out there into, you're able to convert that into what is called as text. So this was the image which was stored, and then on real time you are able to what is called as convert your text into speech. Okay, now once this is being done in the second set, we can also connect a live webcam. But before that, let me just run this part of the code and then show it to you. In this case of the program, what I've done is that I have a webcam. Okay, so I have a webcam connected to my laptop, so I can just come here and then say webcam. list. And then when I press enter, you can see that there is webcam C170, and then there is an integrated camera. Now what I'll be doing is that I'll be able to take this webcam, and then I would be able to what is called as load the live video, and then it has to classify the objects on a real-time scenario. So this is what I'll be just doing it in a couple of minutes. Okay, where you can see that I'm having what is called as webcam. So I have to just change this as webcam 1. Okay, and then I have net, lxnet. So these are different things which are out there. Okay, and on real-time scenario it has to classify different things. Okay, so let's see whether it would be able to classify that or not. So what I'll do is that let me just go ahead and run this. So you can see here it says a stopwatch. Okay, let me just try out with different things here. It says it's a mouse. Great. Okay, stethoscope, I don't know. Okay, stopwatch. Finally, it is able to identify, right? So let me just show the laptop. See, it's able to identify. It has a spacebar, keyboard, monitor, right? So like that, on real-time scenario, you would be able to identify different things which have been placed on the table, right? So it says mouse. Okay, pen, great. So let me just show you this. So with just few lines of code, you would be able to identify different things which are being placed on that corresponding table there. Okay, so I'm just pausing it. And let me just refresh it. Then I can just say quit debugging. Right. So let me just go ahead and explain this corresponding program here. Now you can see that in the first case, what I did was like, what I did was that I just said that net is equal to webcam, and then I can just go ahead and then load the neural network, which is called as AICTE-STTP. Okay, so previously I had used net, right? So I'm just using what is called as, I think it got hanged. Sorry for that. What I can do is just remove this. Okay, quit debugging and clear it. Okay, now what I've done here is that I'm using a camera, which I'm calling it as webcam 1. And then what I'm trying to say here is that I'm saying that load the AICTE-STTP, and in that AICTE-STTP you take a picture, that is picture is equal to camera dot snapshot. So it is continuously capturing video, right? In that video you have to take live pictures, and then once you have taken the pictures, you store it inside a variable called as picture and resize it. Then label that corresponding picture on a real-time scenario, and then you can classify it. In the next section, what I did was that, yes, I just used that same code which we had previously used, where we said I want an object name of whatever labels which I have in, and that whenever you show the object, it has to identify the name of those what is called as objects it has detected. Like if it has detected a mouse, on real time it has to tell that this is the image of a mouse, this is the image of what is called as a keypad, this is the image. I'm sorry, I just typed web, right? So I think this should be again webcam 1, right? So when I run this part of the code, you will be able to convert that into a text. Okay, now there was one question which was in terms of what is called as the number of activation layers, hidden layers, and what are the 25 layers which would look like. All those things can be better understood when we go into the transfer learning. So let's go ahead and then switch into transfer learning. But before that, we have some couple of things which has to be addressed. So as far as deep learning is concerned, these are few of the areas where you can use them. And then what happens during the training is that it will be passed through a layer of convolution rectified pooling layers, where the layers are learned during the training process. So what are the weights which are being determined? How the weights are determined? Basically, these weights are determined by the training. So this was one question. I think this has been answered by this. So how the weights are determined? The weights are determined based on the, or these are learned during the training process. And how is the training process? Training process is of two types. One is called as training it from scratch, and the other is from transfer learning. So transfer learning requires less amount of data. So that's the reason we'll be training and creating a convolutional neural network using what is called as transfer learning rather than doing it from scratch. Okay. So once this is being done, what happens during the first convolution layer is that you can see this is how the random weights have been determined. So you can see that the number of epochs also varies. Okay, so how to determine these number of epochs, right? So I would basically use what is called as there is a model which you generally generate in, where when the training process goes on, you would be able to determine the accuracy as well as what is called as the error. Okay, so minimum error with highest accuracy, say somewhere around, I can go ahead and set my accuracy to 95%, and then I can just give an epoch at least somewhere around 10. So during that epoch, each and every sample of data set would be trained, and then it will start giving me the output. But imagine your accuracy is reached somewhere around 75%. Is that model would give you better efficiency? No. So again, at that case, you would be going ahead and then increasing the number of epochs. Okay, and then there are different training options. Okay, so in MATLAB there are different training options. When we go to the transfer learning, we'll discuss on that. Now, as far as number of iterations, pyramid level and pyramid scale, you can see that there is a deep dream image. So the fully connected layer, channels, and number of iterations, whatever net you are using in, that is your LXNet, ResNet. So whichever convolutional neural network layers which you're using in, you can use them extensively and then process that data on a real-time scenario. Okay. Now, whenever you want to visualize the training data set, so can you tell me what is this image all about? Anyone in the chat box? See, it depends. There is one question here, sir, to access for control, which learning technique can be used? It's basically to access control in IoT. See, whenever you are working with machine, it will be sensor data set. So it's basically a permutation and combination method. So based on your data set, whichever machine learning algorithm gives you better efficiency, you can go ahead and then you will be able to get the corresponding output. Okay, now whenever you talk about what is called as visualizing the data, you would be able to use uh, the data here. Now the data which has been loaded here is the image of an attic fox, right? So there was a right answer. It took somewhere around 17 I mean, in the first epoch itself it is able to identify that, but at 17th epoch it gives an highest accuracy, stating that yes, after 17th epoch you can see that the accuracy would be somewhere around 90 to 95%. Okay, so like this, the images at each epoch, the machine would be able to identify them in a real-time scenario. Okay, now in this slide here, this is the image of a flamingo, right? So for a normal person, when you show a lot of images, for the first instance, he'll not be able to identify that in what is called as at a go. He'll take some time. But imagine machines, when it gets trained with large amount of data, at epoch 1 itself, it is able to identify that this is the image of a flamingo. And then at epoch 95, you can see that the accuracy level goes on increasing. Now, once this is being done, we have two approaches to perform transfer learning. So your questions were uh, like, what are the hidden layers, how do I choose it, if I'm working on a control system, right? So are there any optimization algorithms which are out there? Yes. So all these statistical and machine learning algorithms, the best option is to start up with what is called as statistics and machine learning ka toolbox. If you go to MATLAB website, there is a product portfolio page. There you go into machine learning, and then you can also go into the deep learning product portfolio, and then there is reinforced learning also. So if you're working with control system, it's ideally you go ahead with the reinforced learning, which we have not covered here. Okay. So as far as deep learning network has to be developed from scratch, they you have to develop the entire architecture from scratch, where you'll be requiring large amount of training data. Okay. And then there is another method where you perform what we call as transfer learning, where you fine tune the algorithm by using the pre-trained models. Like AlexNet is developed by a set of researchers who have spent almost around a decade in developing that. They had trained the images with somewhere around 1,000 classes with 1 million images in it. So which are those images will just show. uh, Whenever you are performing what is called as deep learning, there are two approaches which are being generally followed in. Okay. So one approach is where you would be performing what is called as training from scratch, where you would be requiring training data which is of hundreds to thousands of labeled image data, and the computation which you require in is your normal computation. Okay. But imagine if this amount of images are there. Okay. It would take a lot of time for you to actually process the data and then to give you the corresponding output. Imagine the same thing is happening with a training time of few seconds. What you'll be doing is that you would be going further, and then you can build or make functional changes in terms of the number of epochs, and then try to increase the efficiency of it. But if you go for developing training from scratch, what happens is that the model accuracy would be very high, but look into the training data. The training data would be very large, and then it would require what is called as computation, which is very intensive, and generally it requires a GPU, because if you are having thousands to millions of labeled images, those when you are performing training, each and every image would be considered, and then you'll be performing training on them. Okay. And then the training time, basically it would require a week for such real problems when you're trying to perform. But as far as accuracy is concerned, the accuracy would be very high. Okay. Now in this section, our focus would be in terms of what is called as transfer learning, where instead of you developing what is called as networks from scratch, it's ideal that you use the pre-trained network, because uh, the researchers have extensively worked on that area, and then you can leverage their networks. Okay, the best networks which they have created in by the top researchers across the world, and then you can perform or pre-train it, and then you can create your own networks which can be used in classification of data on a real-time scenario. So in this regard, we also have what is called as AlexNet, VGG16, VGG19, which has the greater representation. So what are the pre-trained networks which are out there? So these are few of the pre-trained networks, and then you can load these pre-trained networks by just using one line of code. Okay, so you can just go and then say net is equal to AlexNet. We just saw that we were able to identify images, as well as we were able to identify, convert that classified data into voice. You can also use Google Net, Google Net, Inception V3, ResNet 50, ResNet 101. So ResNet 50 and 101, these were the two neural networks which we had extensively used it for signature classification. We had used Inception Net V2 basically for what is called as MRI scanning or MRI image recognition. So such kind of things where we are trying to identify fractures. So such kind of things we were able to work with Inception ResNet V2. And then you also have Google LeNet, extensively used for computer vision modeling. So one such demo, let me just go back to MATLAB and then show it to you. Okay, I have it here. It's webcam one. Yeah. So in this case, okay, so let me just go ahead and explain each and every command one by one. So I have webcam C20. Okay. Now what I'm doing is that I'm passing one line of code where I'm saying that turn on the camera. Okay. So I'll just say camera is equal to webcam 1. Okay. And then when I evaluate this particular section, it would turn on my camera. So there is an webcam which is being created in. So when you run this code, you can see that your camera gets activated. Now after that, what I'll do is that I'll load the network, that is a convolutional neural network, that is net is equal to lxnet. Now I have loaded that corresponding network now. Okay. Now there is a question like how do I check what is called as a classify the snapshot. So I'll just say that input size is equal to net dot layers, and then input size 1:2 is what I'll be just trying to do. And so I'll just go ahead and run this particular part. Okay. So in case of lxnet, you were resizing the image as 227 cross 227. In case of google net or google net, it is 224 cross 224, the pixel values. Okay. And then once that is being done, it has to take what is called as uh, pictures, that is you're passing a variable called as take snapshot using what, using the camera, store it inside an image, and then you have to label the image. But here we are pointing out a important thing here, that is the labeling should happen based on score. So whatever image it is capturing in, that image ka real time score it has to display with an accuracy value. So let me just go ahead and then say run and advance. So it says pick. Okay, I think just close this, click here, and then run. Okay, what happened? Okay, let me just clear this. See, right? So you saw that even though the image is shabby, you can see that it says it is a mouse. Okay, and then it is able to display that on a real time. And then if I want that image to be continuously displaying the value, I'm using a while loop. Okay, now during this while loop, what happens is that it will be start predicting what is called as the images on real time. So if I go ahead and then run that, you can say that it is telling me that it is a mouse, it's a bandit, whistleblower, cleaver, wallet, projector, computer keyboard. mm, right, it's saying that. Okay, right, 98% it is telling me that it is a, but why my I mean the watches and all are not able to get classified. I'm just saying that it's a stopwatch. Okay, right. So like this, you would be able to classify that. Okay, let me just go ahead and then close this, and then I can just say run it advance. Now what I'm trying to do is that on real time, it has to identify different things here. Okay, so this is with respect to a figure. Okay, it told me that the image which you displayed is a figure. And now if I go ahead and then say run and advance, can you see? 1 second. I think I can just, yeah, this would be ideal. So it's telling me that I'm trying to draw a bar graph. Okay, I'm trying to draw a bar graph where in the bar graph you can see that it is able to identify that whether it is a mouse, whether it's a laptop, whether it's a sunglass, okay, or whether it's a wallet, it's a binder, right, keypad. Okay, on real time it would be able to do that. And then on the right corner you can also see that it is able to give you the corresponding output. Okay, so like this, you can go ahead and then you can build different applications on whatever model which you have created it. Okay, now this is with respect to whatever program you had in, where you were continuously taking the snapshot and then you were resizing the image and then displaying the score in terms of a score plot, where you are plotting it in terms of a bar H and then displaying the label as X label, Y label with the different limits associated to whatever model which you have created. Okay, so let me just come back to our presentation. So we just saw LXNet as well as Google NearNet in combination with computer vision for image identification as well as classification of model. And now you can use these particular models and then also perform what is called as transfer learning. So what is meant by transfer learning then? So whenever you try to perform transfer learning, okay, so there are different things which you have to, which you require in. So transfer learning basically would require a network, a training data, and then you would require an algorithm options there. Okay, so these are the things which you would require as a checklist whenever you are trying to perform transfer learning. Okay, please make a note of it. Please make a note of it. Okay, so once you're done with that, like whenever you go ahead with transfer learning, okay, the first thing is that you have a network and then you would be having a batch size where you tell that the maximum iteration and the learning rate, you would be mentioning it in your program. The second thing is that you would be requiring a network training data and the algorithm options, which you would be mentioning in your program. So how do I do that? So to do that, you will be mentioning train network, and the syntax would be net data and options. Okay, so this is what you would be using it, and then you'll be performing what is called as transfer learning. Now what is meant by transfer learning is that, as we discussed, like if I want to see the number of layers in what is called as LXNet, okay, first thing I'll be loading is my network. Okay, so what I can do is that, let me just come down here to my MATLAB. I think someone had a question. What are the data sensors that can be used for online class session? Uh, I did not get your question. Can you just point out? And someone raised your hand also, I think. I don't know. Yeah. So whether the students are engaged or not, I would suggest that it's ideal that uh, I think in my one of the slide we have an automatic what is called as attendance system, right? So the student has to continuously sit in front of the monitor and it would take the attendance live. Okay. So we have already developed that. It was for one of the customer in what is called as Mangalore, and it's for engineering college, and it was for one of the funded project, and we have developed that. We'll just show you those demo also. Okay, the students cannot bunk the class, especially in the live. Okay, I think they are coming with the app for that, and then I think that would be integrated, and it will be uh, I hope that's one way where you can see that students are keeping them engaged. I think it's ideal that you come up with small miniature things with some statements where they can come up with some coding, say small codings which you can do in. I would suggest that you can use like uh, a small quiz kind of thing, or give them tasks in terms of small programming where they can program it and then revert back to you. Okay, so like based on the concepts you can ask them to do it. So there's a grader, okay, MATLAB grader, where you can pass those questions, and then they have to revert back. It will be like whatever the quizzes are there, right? In the same way, they have to perform execution of MATLAB on their MATLAB mobile or on LAMP. So there are different places where you can use MATLAB or Python also. Nowadays, if you have a Gmail account, you can directly run your AI ML applications directly on the uh, what is called as Google Colab, right? So such kind of things you can uh, yeah, students are looking at the screen. For that, I have a attendance monitoring attendance system. I'll just show you that. It's there in industry already. Like it's there. I'll just show you that. Okay, give me 1 minute. Let me just clear everything. Yeah. Yeah. Okay. Now come down. What we are trying to do is, let me just quit debugging, clear everything here. This is one of the important thing when you perform transfer learning. This is one of the important demo which I generally spend couple of minutes. And after this, we'll be going into the COVID data set. Okay, so these are the two things which I'll be using and then mentioning about transfer learning. Okay, now in the first thing, what we'll be doing is that we'll be using a deep neural network, which is also a convolutional neural network. That's your pre-trained network which we'll be using in, and then we'll be loading those images, and those images would be loaded using image data store. Okay, now if I come down to my folder here, that is this location. Okay, so do I have that location here? Let me just go and okay, so you can see here I have internship, AI, right, workshops. Let me just go into workshop. Yeah, so you have day 5 here, and then you can just see there is a folder called as image set final. Okay, now if I open this, you can see that there are multiple images here. So it is inside the location D drive, uh, final day 5, and then you can just see image find dataset. Now, as we discussed, like in our first slides, whenever you are working with machine learning or deep learning, you should be having ample amount of data. Now, since this is transfer learning, you can see that I have multiple images stored here. So these images are images associated. I can just go here and then say open. These are images associated to truck, car, SUV. Okay, so like this, there are different images which have been stored inside that corresponding folder. But whenever you store these images inside those folders, see to that they are labeled. Okay, so you can see that the images are not individually labeled here. So in previous versions and all, we had to go ahead, and then if there are 500 images, on each and every image we had to draw one bounding box, like how we did it for the vehicle detection, right? So like that, we had to draw a bounding box, and then we have to mention that this is a truck, this is a SUV. But in case of transfer learning, nowadays you can just label the entire folder, but see into that the folders are being stored in such a way that it only has the images of car only. By mistake, you put some bikes and you put some other images here, okay, and then you have not checked it precisely. At that time, it will start giving you error. So we have 1, 2, 3, 4, 5 set of folders which have been stored here inside what is called as the day 5. But your program is inside this transfer learning folder. So that's the reason in your program, initially, you can see that I am loading the image using the command called as image data store. Okay, so what does this do is that it would load whatever images are there into what is called as your MATLAB uh, workspace. Okay, now what it will do is that it will load the data or include that corresponding data, and then you're telling that include the subfolders, and then you label the subfolders with their specific folder name. So you're just loading the input image, and at the same time, you're using structures where you say that IMDS count each label. So whenever you have labeled those folders, inside each folder, you count the number of images there. You're trying to tell that. So I hope these two lines of code is clear. I can just go ahead and then run this now. Now what it will do is that it will first say that yes, total inside those folders, there are images of big trucks, car, SUV, okay, trucks and vans. So each folder has more than has more than 200 images. In case of big trucks, there are 201 images there. Okay, so once this is being done, what you're telling is that, okay, now you have loaded or you have those images available with you. What I want you to do is that I want you to split each label where you say I is equal to 1 is to 5. So out of each folder, you take one image and store it inside the variable I, and then use the subplot command and display those images for me, is what you're telling here. Now, if I go ahead and run this part of the code, what would happen is that it would display those images with their specific names, saying that this is the image of a car, this is the image of a truck, this is the image of SUV, this is the image of a van, and so on. Right? So once this is done, okay, what it will do is that you would be able to divide the data set. As we discussed morning, you're dividing the data set as training and testing. So in that, you are splitting the data set. So you say that split each label of whatever data set which you have stored here in this IMDS, okay, split that into how much? 70% for training and 30% for testing. So IMDS 70% take random data and then perform the training of it. Okay, so that is what you are trying to do there. And then for that TB1, okay, where you are counting the training data set which has been stored here, which is how much? So you're just counting the number of big trucks, cars, SUV. So total is this much. When you divide them into training set and testing, that means 70% of this should be for training, and that number you display, you're mentioning that. So if I just go ahead and run this section, you can see now your TB1, which is nothing but your training data set, is having how many images? It is having 141, 140, 140 images in it. Now, which was the network which we are loading here? We are loading net is equal to LXNet, right? So when I say net is equal to LXNet, what happens is that it would load the neural network. So I can just select that and then say net is equal to LXNet. It is busy. So the convolutional neural network, you can see the net layer is being created in. Now I can just click and drag and drop, and then I can press enter. You can see it's a convolutional neural network layer which has 25 layers in it. Right now, if I want to load the layers, I can just say layers is equal to, look into this layers, I can just say net dot layers. So this is the answer for the second question. You said that how many layers are there? How do I determine that? First, load the network, and once you have loaded the network, you can just go ahead and then say net dot layers. It would give you the number of layers in each CNN. Right? So I can just select this, right click on it, and then say evaluate section. So you can see this is the 25 layers. Okay, so whenever AICTE-STTP or Dr. Alex and his team developed this AICTE-STTP, they had used somewhere around 25 layers, and each layer has different what is called as arrangements in terms of like they have used a 227 cross 227 cross 3. That's a colored image they are using in. They are performing stride padding, zero pooling they'll be doing in. They'll be performing normalization, basically standardization and normalization. There are two methods. Okay, so they have performed normalization with 5 channels, and then like that there are different layers like this. So you as a person, you did not scratch your head in developing it from scratch and then coming up with a convolutional neural network. It will be ideal that you look into this network and observe here. So the fully connected layer had how many classes? It had 1,000 classes. As I said, AlexNet was trained with 1,000 classes. Now in our case, what we'll be doing is that we would be replacing that 23rd layer. Okay, so you say that 25th layer class name out of that 100 classes, you're telling me that, okay, you tell me the class name of 25th layer name. So I can just go ahead and then say evaluate section. It says this. Now I can just go here and then say 212, and then I can evaluate. Okay, it exceeds. I think I can just say, I'm sorry for that. I think I can just evaluate this much. Just give me some problem here. Right. Okay, it's not able to identify it. Anyways, now let me just keep it as 25 only. Okay, now we just say CLC, and let me just say layer 25, and then let me just run that evaluate section. Now when I go up here, okay, so I'll be able to see all those layers. Okay, so if I go here, I can just see like which are the images. If I take a transpose of it, you can see all those names here. So all those 1,000 class of images, you can see the names of that. Okay, so on these images the AlexNet was being trained. So it had what is called as binder, it had barber shop, it had lionfish, it had what is called as water buffalo, it had ringlet, monarch, tiger. So these were the images which were used when they were training what is called as the AlexNet. And in that 25 layers you have determined the class names. I just wanted to see in 5 layers which are the class names, but it will not show me that. Okay, so it's ideal that you take all the 25th layer and then you want to show the class names associated to it. Now once this is being done, what is transfer learning? What did we define in transfer learning here? So this is that 25 layers here. Okay, in those 25 layers, what I'll be doing in transfer learning is that I can just go here and then change this 23rd layer, which is nothing but your fully connected layers. Okay, so 23rd layer which is out there, you will be changing that fully connected layers, and then you would be what is called as adding up, okay, or changing this based on whatever image data set you have. You had how many? 1,000 images, 1,001 images, right? So that you'll be replacing. To do that, what you do is that you'll be just mentioning 2 lines of code where you're telling that, okay, the number of objects height is equal to train.ds, count each label, and then layer 23rd layer, that is your fully connected layer, comma name, that is FC8, and then you'll be classifying the layer on my new classifier. So if you mention that, you are actually changing that now. So you can see previously here the fully connected layer, it was showing how many layers? It was showing 1,000. Okay, 1,000 fully connected layers. Now it is able to show you that 5, because in your data set there are only 5 set of images. Okay, and then for fine tuning you can go ahead and then mention the learning factor here. So this is where you mention the learning rate factor and the biased learning rate. So I had told you, as we go with the hands-on we'll be discussing on it. So you can obviously go ahead and then boost this rate, but it depends upon your computation speed. So I just start up with 10 and 20, and then I can go make changes in that. But generally what happens is that there will be either overfitting or the system generally gets hanged. Okay, so it's ideal that you start up with 10 and 20. Okay, now once I go ahead and run this particular thing, okay, and I can just go ahead and evaluate the function. And here I'm mentioning the batch size. where I say that, okay, the batch size is 16. That means the number of input images per process is 16. The maximum epochs, okay, so one epoch would complete the entire training data. That means 1001 images it will take. And then I can go into ops and then say training options, where I can just display the what is called as the training process has begun or not. So if I go ahead and run this part of the code, you can see that it would be mentioning the training process, and then it will start up the training with couple of minutes, where we would be able to determine the training of the corresponding data, where you will be able to perform the input validation and various parameters. You have also used the command called as TikTok here, okay, which would tell you the time of what is called as time duration, which it has taken to perform what is called as the training. Okay, you can see that the epoch has started, the training process has started, and hence you can see that the training accuracy is varying with respect to time here. Okay, it's also changing with respect to the iteration. Okay, so in our program we had mentioned that I want an accuracy in my training options. You can see here I have said that the maximum batch size is 16, epoch is equal to 20, and then I have given the initial rate as 0.01. So if you just go here and then say training options, you can get this entire syntax. Okay, we have just copied and pasted it here. And then the batch size is somewhere around 64, and you're trying to display that. I think here you can see that in the function I have said that my accuracy should be at least 99.5. After that, you stop the training process, or you can halt the training process. There was a question like how exactly, or when exactly, or how many epochs I have to give. All those questions, I think this demo would have explained the answers to that, like how do I give the batch size, how do I mention the training options. All those things are syntaxes which you can go ahead and make functional changes in it, play around it, and whichever gives you better accuracy, faster accuracy, okay, those algorithms you can use it and export that model and save that corresponding model, and then you can use that model to classify the data on real-time scenario. Okay, so let it perform its transfer learning. Let me just come back here. What is the steps involved in transfer learning? The steps involved in transfer learning is very simple. First, you should be having a network, right? And then you should be having a set of data. And then based on the data, you would load the network, load the data set. And based on that, you go ahead and then change the fully connected layer from 1000 fully connected layers to the number of layers, which is 5 or 4 number of layers you'll be mentioning it. So the process is very simple. The first step, what you'll be doing is that you'll be loading the pre-trained network. Once you have loaded the pre-trained network, you would replace the final layers. Once you have replaced the final layers, you would be going and giving the training options, where you mention that hundreds of images or thousand, tens of classes, and then the batch size and the accuracy, all those parameters you will mention. And once that is being done, you would be able to predict and access the network or the model. That's you'll be getting a trained network. Once you have received the trained network, you would be passing a new set of images through the trained network, and then you would be able to classify those images on real time, where you would be able to perform transfer learning on a real time scenario. Load the pre-trained network. In the pre-trained network, go ahead and replace the final layers, okay, with the number of specific to your data. Perform training once again, and then you will get a model, pass the new set of input, and based on that you would be able to classify the image. So whenever you are having only images of those data set, the accuracy would be good. But if you are doing it from scratch, the accuracy would be very high. Okay, so let me just come down here and see how is the training now. So you can see that uh, it started up from 10 here. The accuracy went up to somewhere around 45%, and then it again came down. It's incrementing. So it has to reach somewhere around 90, and after 90, it should be stable. And once the algorithm gets stable, you can go further there and you would be able to get the corresponding output on a real-time scenario. So let me just wait for a couple of minutes. Yeah. Yeah. So the first thing, as we discussed initially, we said that okay, whenever you want to perform transfer learning, you should be requiring what is called as a pre-trained network. So these are the three things which are required in. So one is your network, the second is your training data, and then you have the algorithm options, right? So algorithm options directly in MATLAB, there is a syntax which you can use in, and then you can play around in terms of batch size, number of epochs, right? So generally, don't keep more than 64 epochs or the batch size, learning rate. All those things matter whenever you are having a low-end system, right? So it's ideal that if you have an i5 system and then you are having what is called as even uh, a normal SSD card which is there in your system, that would be ideal, which can be used for processing the data. Okay. Now, once this is being learned, you can just go here and load the network, and then under data there are different options. Okay, for training or performing transfer learning, you would require what is called as a neural network, that's your CNN. You can load the data, and then there are options in it. Okay, so first thing, I can just go and write a command, net is equal to lxnet. Okay, and then once I've said net is equal to lxnet, what I'll do is that I'll use imds command, that is imds data store command, and read all those images which are out there. Showing you the layers, all those things was just to and make you understand like what are the layers which are out there in the loaded convolutional neural network. Okay, now once I say once I have loaded the images, I take the count of number of images. Okay, and then I have to perform training to a machine, right? So I have to divide my data into training and testing. So 70% would be kept for training and 30% is kept for testing, right? After that, I load the network, check the layers, 25 layers. And when I observe the layers, LXNet was trained with how many layers? 1000 layers. But what we are trying to do, we are trying to classify the images with just 5 different category of images. So the fully connected layer will get changed into what is called as 5 layers by just 2 lines of code. So whatever that fully connected 23rd layer is there, you replace that with the number of images or number of data you have in. Okay, so based on the batch size, you change that layer. So this fully connected layer would become 20 or 5 now, and then you perform training from scratch. Now, once you redo the training, what happens is that it will be able to perform the operation. Now, let me just go to the code once again and do the same thing or explain the same thing once again for you. So this was the code which we had pointed out. First thing, we said IM data store, double dot, that means 2 folders back, I have stored all the images. If it is 3 dot, you have to store the images up before 3 folders, and then include the subfolders, and each folder is being labeled there. Once that is being done, I count the number of images. So what we got was, what result we got was that each folder has 200 images, and in one folder, that is big truck, we had 201 images, right? After that, we check and display the images, that is in this part of the code, we split that and then display the images as take random images from each and every folder and display those images, and then give a title to it. Once that is being done, you divide the data set, that is split the data into 70% for training and then another 30% for testing. Okay, once this is being done, you say that net is equal to lxnet, and then you say layers is equal to net dot layers. Okay, so when you say net is equal to lxnet, you have loaded the lxnet convolutional neural network, and then when you say net dot layers, what would happen is that uh, it would point out all the different layers out there, and inside that layers you want to know which are the classes which were trained, like which are the set of images. In our case, we have 5 set of images like big truck, car, SUV and all. But in case of LXNet, there are how many classes? 1,000 classes. So I want the names of those 1,000 classes. For that, I'll use a command called as layers25.class names. Now, once this is being done, you can go ahead and alter those two layers by just 2 lines of code. That is, net23 is equal to fully connected num objects. Basically, whatever that trained data is there, okay, it is telling you that you had 5 categories. So you change that 23rd layer with this layer, and based on the number of classifiers. So based on your training data set, you change the layers there. So once that is being done, you go ahead and then mention the weights, okay, the learning rate as well as the bias, okay. So those things you mentioned. So the learning rate I give it as 10, and bias I give it as 20, and then I just go ahead and then plot the training accuracy. Okay, so for that I'm setting that the stop the training at a threshold of 99.5. You can also give 95.5. It will not take so much time for giving you that accuracy. Now you can see it has reached 93.75. Okay, and in the second case, if I come down here, you also would be mentioning. So if you want to tune the network, you go here in the documentation and search for training options, okay, or train CNN. It will give you this entire syntax, okay. And ideally, see into that the number of batch size you keep it as 16, and the number of epochs you give it as 20, okay. And then to know the time duration, you are using the command called as TikTok here, which would identify the time duration of this entire model. And then you can just say test classifier on validation set, and then you would be able to classify, and whatever that data is there, you'll be able to save them in terms of a saved labels in whatever folder which you're having. Okay, so this is how you would be able to perform transfer learning. And then you can also go ahead and then display confusion matrix, or you can also test the confusion matrix in terms of various things which you want to do, but that's not required in terms of our model. We just wanted to know how exactly transfer learning is being performed. Now, as far as the accuracy is concerned, let's see where the accuracy has reached. So now you can see that it has reached somewhere around 95, but it is again dropping in. So once it becomes constant, you can see that the model would be able to give you a better result. Okay. So this was with respect to transfer learning. Okay, so the same transfer learning can be done for food classification. So this kind of projects you can arrive or make your students to work once the concept has been done. Okay, now we have developed one algorithm for the Flipkart where they want to classify what is called as the data associated to different inventory. Like it might be OnePlus 60, or it might be the different phones. Every year you can see that the number of phones sold are very high, so packing of that would be very difficult. So if you have a robotic system which can identify those images on real time, so how much lines of code would require? That is one of the thing. Now if I'm trying to do that, okay, I have a set of data which is having these data set where I have French fries, burger, pizza, sushi. These are the set of images which I have. And then what I'll do is that I'm performing deep learning for image classification, where I take French fries, pizza, burger, uh, hot dog, and ice cream. And then I take a camera. And then what you can do is that this is a Microsoft camera, which you can purchase it via Amazon. And you can see on real time with just somewhere around 5 to 6 lines of code. Okay, so you can see that you're just loading the mat file. So now we just perform training, right? So if I save that entire output or model as a mat file, later I can just load that mat file, and then if I go ahead and then perform what is called as transfer learning, or whatever the transfer learning mat file I have, I save that and then use a webcam to use that mat file to classify that image on real-time scenario. It will be able to give you better accuracy. So like this, you will be able to classify the data on a real-time scenario. So whenever you want to train a food classification network, first thing is that you load the data. Second thing is that you load a pre-trained network. When you say that net is equal to LXNet, and then you say layers is equal to net.layers, and then you can go ahead and then finally replace those layers, where you say end is equal to replace that, and then finally you would be able to what is called as opt the training options there, when you would be able to perform the training of that corresponding data with just 8 lines of code. You would be able to perform transfer learning. First thing, create a data store. Second thing, load the network. Third thing, replace the final layer. Fourth thing, set the training options and the training network methods, right? So we have just already done that. So someone was asking like, how do I keep my students engaged, right? You can see here, these are the two things which we are able to do. When this is in terms of emotion, when the person is neutral, when the person is sad, right? If the student, I mean, whenever you are taking live classes, you can understand whether students are able to follow you or not, right? Like whenever I do workshops, I generally observe that their facial recognition tells you whether they are able to understand the concepts or not, right? Similarly, this second thing what we did was like using the facial detection. You can see that automatic attendance system where it is able to identify the name of Varsha, Samir, Naveed, okay. And the only thing is, like, if you hold your mobile phone with the person's photo, he'll get attendance. So no need of proxy there. That's the only thing. I don't know like how to figure it out. So you can see that you are showing the image, okay. When it sees that okay, the image matches with someone's facial recognition, I mean the CNN, they extract the features, and then on real time you'll be able to identify. So this is one of the solution which we created it, where you can keep your students alive and engaged, okay, and you can understand like who is uh, listening to you and who is not, okay. And then once this is being done, you can also see that uh, we also have what is called as running this data on hardwares. So in the next session, I think probably in phase 2, if we are doing sessions, we would be demonstrating these on these hardwares like FPGA, NVIDIA Jetson Nano. So today I just showed you like how exactly you are able to perform classification, identify various things using your laptop, right? But how to run this on TX1, TX2, or it might be Ping platform, where you can need not be only MATLAB, you can do it with Python also, which is very simple, okay. So if you want to program an FPGA, we had an analogy where we had to study Verilog or VHDL, but that is not required, okay. You can using Jupyter Notebook these days, you can also program what is called as your FPGAs, okay. So how to do that? If we have time, we would be able to do that in our next session. Okay, there is one question which is from Bhuvaneshwari P. Yes, yes, ma'am. You can unmute and you can. I think I am not able to unmute. You can just put it in the chat box, ma'am. I'd be happy to address that. Thank you, sir. I'm not done with my session. Please be there. Uh, okay, please be there. I just have to cover with the COVID data also. I'm just waiting for my results here. So you can see it has reached 99%. Now, once it reaches its 99%, you can see that it will tell you like how many epochs it has taken. So somewhere around we are told that, okay, you have to take maximum of 10 epochs, right? So you can see that it has taken 10 epochs, and with those 10 epochs, it has reached an accuracy of somewhere around, okay, it has reached an accuracy of 100%. Great. Right? I can just go here and then say save, and then I can just save in bracket. Now you can see it would save that entire mat file. Okay, let it save itself. Now this is the accuracy which we had gotten. Now once this is being done, if you take this further, so you can also whenever you are working with multi platforms, like as we discussed, like you have different platforms, like we have NVIDIA Jetson TX1. It might be on your Android phone also, or Intel desktop PC, or Raspberry Pi for that matter. Nowadays Raspberry Pis you get it for 4.5, right, for 4,500 rupees. And then using that also you can develop your deep learning algorithm and then deploy those algorithms on those hardwares. Okay, if you're trying to do some patents and all, these are few of the hardwares which you can look into and then deploy the algorithm. So it might be in terms of autonomous solutions. These are the platforms which have been extensively used in terms of industrial solution. If anyone is interested in terms of purchasing these platforms, I think Ramesh Naidu would be the right guy whom you can contact, and then he would guide you with the rest of the stuff. Okay, so before I wind up, just last demo, if you have time, I have another 15 minutes. Let me just stop it here. Was it? Just quit debugging, and then I can just say clear. Okay, so everyone, this is one of the place or location where we are getting the X-ray images of COVID test patients. Okay, so using this, I'm just sharing this across in the chat. Okay, so this is where you would be able to um, get the data set. So you can just go here and then download this corresponding data set from here. Okay, now once you have downloaded this, where is it? Okay, so this is my location. That's my code. Just come here. This is also a transfer learning example. So that's the reason I have taken this. Now this is the COVID data set. That is, there are images of chest X-ray. Okay, so this is where the data set is all about. You have images here, documentation of various things here. So you have COVID patient ka data, I mean the images which are out there, and then you would be using this corresponding data set to actually identify various parameters. Okay, let's go ahead and do that in a couple of minutes. So I have, okay, so I say that, okay, clear all, close all CLC, load the image data set, include the subfolders, true, and then label with the folder names, right? Now, once that is being done, let me just run this. Okay, let me just explain this and then run this. Okay, once this is being done, what you're telling is that you display those images in terms of subplot as we had done. The number of folds, you are given it as 10, and then you pre-process that every set of image, and then the subset of each folders also has to be taken in, and then you divide that data in terms of current folder, and in that you use an algorithm, that is your convolutional neural network. You use net is equal to ResNet 50, right? Previously we used AlexNet, GoogleNet, Google LeeNet, right? And then now we are using ResNet 50. Okay, and then clear the network, and then you can check the number of categories, and then whatever that layers are there, in that you will just say the weight factor as, the learning factor as 10, and the bias learning factor as 10. Previously we had given it as 10 and 20. Okay, and then in the fully connected layer, I'm sorry, what's happening here? And in the fully connected layer, you will be replacing those layers, okay, with the input layers based on whatever data set which you have, and then perform what is called as the training. Okay, once the layers have been changed, you perform the training and then augment that corresponding training in terms of a graph. Okay, so that is what you are trailing in, where the augmented data, because Google LeeNet in the previous example we saw that it is in the image form, would be resized in 224 comma 224, and then you would be able to resize that corresponding image, and then you would be able to plot them. So let me just go ahead and then run this model. Okay, it says that, okay, there are these number of images there, and then it is processing among one of the 10 folds there. And once the training process starts, I'll just come back here. So let it process. So as we discussed about, we can use NVIDIA platforms for developing automatic driving assistance system. And then if you take it further in terms of developing models where you want to implement that on GPUs, like you have GPU 1, GPU 2, or there might be a combination of GPU and FPGA. So ultra scale boards, okay, nowadays you can see that Xilinx have come up with ultra scale platforms. Okay, there is ZCU 706 and ZCU 709. So these are the FPGAs which have been currently used in various industries. And then, okay, it has given us the output now. This is the image, normal images, and then the lung AV mask, and then that's the image, right? So these are the images. Now it will normalize and then it will perform the transfer learning. So once the training starts, you can see that um, you can see the processing. Now, when we said parallel processing, parallel toolbox, we can use one CPU or one GPU. You can also have two GPUs, or there might be four GPUs also. So you can make 256 cores of this TX2 platform and then make the system work at a faster rate. Previously we had algorithms where, or we had boards where we used to use only FPGA on it. Then came SoC, which we call it as system on chip. FPGA plus ARM platform on the same board, okay, which is the simple extensively used board was Z board, which we also call it as Zinc platform. Then we have Xilinx FPGA, which is ZCU 706 and 709. And then after that, we have ultra scale FPGAs now, where you can see that there would be an FPGA, there would be an ARM, and then there will be also an GPU available in it. So such kind of things where you are trying to identify objects, where there are multiple things to be identified, like people on the road, pedestrians, traffic light, okay, whether it's red, green, okay. So the accuracy should be very perfect in this case. Whereas identifying car or an SUV, if there is small minor changes also, it's okay. But when it comes to traffic light, the accuracy should be high, where the object detection is a computer vision techniques for locating instance of object in image or video. Okay, now the same thing, if I go further with this, this is a summary, but before I sum up everything, let me just come and see whether it has started. Okay, it has started the training process. It is processing it. It's bit busy. So it would classify the data. Why this is taking so much time? Yeah. So this is one more method where you can perform the training. Now you can see that it is at epoch 1. Okay. So the accuracy and the loss, okay, can be visualized in terms of a graph. Okay. So the training process, November 5th, you started at 3:53, and now I have reached an accuracy of 85 plus or 80 plus percent. And look into the epoch, that is loss, right? So based on these consideration, like it has performed four iterations out of 3840. So like this, it will take a lot of time to perform iterations. Okay, so it depends upon the amount of data which you have loaded in. So once your data is able, previously we took a normal graph, but here in this you are using a different syntax, where you are telling that, okay, I want that value to be projected in terms of what is called as a predicted label, and then I want the confusion matrix also. So you are telling that, okay, I want that to be projected, okay, in terms of a graph. And that graph, in terms of the first fold, you are able to see that as the accuracy reaches 100% in the first epoch itself, you can see that the error margin has drastically come down. So when the accuracy comes down, the error margin will be high. Okay, so like this you can perform different iterations. Okay, and this is how you would be able to take the data set, and once the result pops out, like whether uh, the data set is belonging to a COVID patient or not a COVID patient, or identifying the conjunction, all such kind of things on real time, you can do that. Okay, now let me just summarize what we had just discussed. So from morning, thank everyone for being patient. So what we had covered from morning was, we started up with machine learning, and you need not be an expert to perform deep learning uh, without being an expert. So you can perform deep learning by yourself. And then you had used different self-driving car based apps, which were ground truth labeling app and so on. You can also visualize models with just few lines of code, where we had used AlexNet, ResNet 50, GoogleNet. I wanted to use Inception V3 also, but since of the time constraint, I was not able to do that. But anyways, we'll be putting that on clusters and cloud for seamless scaling and training of GPUs and cluster. Okay, and the cloud data. You can also deploy and integrate whatever these deep learning algorithms which I just showed you on hardware of your choice, like FPGAs, GPUs, and various other platforms of your choice. Okay, so that's it from my side. I hope I have not wasted your time, and I hope you have understood at least something during this one day of session. I have tried to give my best, because since it is a online mode, I don't know like what is the effectiveness of my training here, but it was really wonderful. You guys were an wonderful audience, and thank you for the entire team and the college management for providing this opportunity. Yeah.
Hello, Pramod Garu, myself, Dr. Sridhar, coordinator of this program and vice principal, Lindy.
Yes, sir.
Thank you, Pramod Garu. On behalf of Oli Institute of Technology, I congratulate you for organizing this session.
Thank you, sir.
Hello,
Yes, sir.
Pramod Garu. Sorry, there was an interruption between. I received a call.
Yeah, no issues, sir. No
I got
issues.
disconnected. So on behalf of all the participants from various institutions around the country, as well as few researchers and all, and on behalf of Lindy also, I convey my sincere thanks to you for enlightening all the participants here. So thank you very much to you, as well as Ramesh Naidu also. Thank you.
Thank you, sir. Thank you.
And Pramod Garu, one other thing is, in fact,
Yes,
we
sir.
have promised the participants like we are going to provide some material relevant to every topic
Okay, okay.
given by the resource person.
Okay,
So if
okay,
you
fine,
can
sir.
provide, leave some material for us,
Yeah,
maybe
sure,
the
sir, sure.
or whatever, any other PDFs or anything relevant to.
Yeah, I'll just share you the entire PDFs of whatever examples I've covered, sir.
Yeah.
Yeah.
Please kindly share that, so that we're going to maintain a repository of all this material, and at the end of the STTP, we are going to share them to the participants,
Sure, sir, sure, sure.
so that they can go home with a lot of content in their minds as well as physically.
Yes, sir. Yes, yes.
Okay, thank you very much.
Thank you, sir. There are a few questions, sir. Let me just finish it off.
Yeah,
Uh,
sir. Please
yeah,
go ahead.
sir, instead of using CPU in MATLAB simulation, is it possible to implement the design in FPGA or GPU? Yes, ma'am. So that was what I had mentioned in the last part. So there were questions like whether we can implement it on a Raspberry Pi. Yes, we can implement it in a Raspberry Pi, but you have to write your algorithm as a function, or you have to do the code generation, and then you will be able to deploy that. Because code generation, there is a flow. Okay, so that flow is like if I have a sine wave, it is changing continuously with respect to time. So that algorithm, whenever I write a algorithm, it will be in floating points. Okay, so those algorithms have to be converted into fixed point. That would be the initial process which we do, and then we go further where we don't use many inbuilt functions which have been not supported by MATLAB for code generation. And then later, I write the equivalent code for it, and then I can generate code and then deploy it. So with just one click of button, how we generated functions right today in the app, you can directly deploy that on FPGA, GPU, or say your clusters. Thank you, Shiv Kumar sir. Thank you, sir. And I think there is, yeah, sir. Can you again tell the procedure for deploying ML in Raspberry Pi? Sir, ML, as I've discussed, like it's an ARM. So coder products would be there. So what you'll be generally doing is that you'll be having algorithms which will be in floating point, convert that into fixed point, and then see into that you write the algorithm as a function. Like deep learning, I just showed you like create function, right? So from that function directly you can generate Verilog or VHDL code if you're using a FPGA. But if you're using a Raspberry Pi, you can generate embedded C and then deploy the algorithm there, sir. Okay, but you have to have the hardware driver support package to be installed, and then configure your Raspberry Pi to with a specific IP, so that your system and that Raspberry Pi is able to communicate precisely. Then you'll be able to deploy that. Thank you, sir. uh, MOOC, see, there are many trainings which happen in. So I think the AICT website, like this for FTPs, whatever is going on, you can see that there are multiple video recordings there. So after the session, obviously you'll get a link of all the video recordings of AICT FDPs which has happened on AI and ML. So I would suggest you go through that rather than going with the MOOC.
Amma, Amma, oil AC.
Yes, yes, there is a tool. Yeah, there is a tool for this, that is MATLAB coder products you require and the specific toolbox or areas which you're working with. Yes. So for converting the floating point into fixed point, you have a tool called as fixed point converter, which you have to have in your laptop. Thank you, sir. Thank you.
Thank you, Pramod sir.
Thank you, sir.
Yes, sir. Sridhar sir.
Good evening to all the participants. Tomorrow morning, we are having a session by Dr. M. Sabarimalai Manikandan. Sir is an associate professor from IIT Bhubaneswar. He is going to talk on machine learning based biosignal and image processing applications with use cases. And in the afternoon, we are having Dr. Devi Prasad Dogra. Sir is also an associate professor from IIT Bhubaneswar. He is going to talk on applications of AI and ML for visual surveillance. So I request all the participants to stay tuned and take an active participation in the tomorrow's sessions, because both of them are stalwarts in those areas of research. So requesting all of you to kindly make the best use of all these lectures tomorrow. Thank you one and all for your patient listening. Answer Garu.
Yes, sir.
You can wind up and.
Okay, thank you, sir.